Okay, so if we look at the data sheet, if you go to pin configuration, you notice the 18 mega 32 AP chip that you find on the Arduino Uno R3. You've got the right pin correspondence. For if you look at where the notch is, you count from your left-hand side, that is pin 1 downwards. And you have this one with 2K byte of SRAM. So first of all, if we have a look at the Uno R3 development board, you've got the 18 mega 32 AP chip. That is the one that we are interested in. And the 18 mega 32 AP, you've got the 3 ports on there. So you've got port D, port C, and then you've got port B on there for you to use. Each of them is 8 bits. So you've got 0 to 7 for port D. You've got 0 to 5 for this side, the other side of port C that you can have access to as well. Port D is connected, port D and B are connected to the digital pins, and then port C is connected to the analog pin. So we realize if you want to have access, so a bit of just not too much details, if you want to have access to port D, you have port D is connected, D2 is connected to pin 2, and then D5 is connected to pin 5. So let's say if we go to Tinkercad, we have the 18 mega 32 AP chip on there for you. If you hover over any of these, you've got digital pin 0, digital pin 1, digital pin 2. So PD2 is connected to pin 2 of. And void loop, we need to set up in the loop function for the Arduino code to run, right? Because without it, we will have an error, which is arguable. We will find out by the end of today's session whether we need these two functions at all the time. Even before we make use of any tangible code, we are already using 444 bytes of memory. 444 bytes, right? 444 bytes for doing nothing really. It's just the setup, the loop, and then this setup of loop function make use of a lot of memory. So that's what motivated us to find out ways that we can start reducing the code that we write. And to do that, we needed a bit of understanding of the CPU architecture, and that's the motivation for the whole thing, or in terms of where we have gone